So we are in quarter 2, module 3, simplifying expressions involving integral exponents. So we have to remember the laws of exponents, wherein this is considered the base. If the same base by the product rule, same base, just add the exponent. So if this is x to the power of m times x to the power of n, you just add m plus n. So the answer will be x n plus n. Same thing with the quotient rule, you just subtract the exponent. And this is what we call the power of zero. So any term or any number we raise to the power of zero, the answer is 1. And we have the power rule, product power rule. If there's no base in here, you just multiply the exponent m times n. That is x to the power of mn. And this is what we call the power of a quotient. So all you have to do is just manipulate by simply getting the exponent of x, x to the power of n, over y to the power of n. And same thing here, this is what we call the negative exponent. So make it sure there is no negative exponent. You have to simplify by getting the reciprocal of x over y. Instead of x over y, you have to interchange. You get the reciprocal, that will become y over x. So the negative becomes positive. So we have here example 1. We have to simplify 3 raised to the power of negative 2. To make it simple, you just bring down 3 to the negative 2 in the denominator. So 3 becomes positive 2. And you remain a to the 8 since the given is already positive. So that will be a to the 8. And b to the 7, you just bring it down, b to the 7. And the 9 to the negative 2, you have to put into the numerator. It will becomes 9 raised to the power of 2. And a to the 5, that will becomes a to the positive 5. The negative becomes positive because you switch from denominator going to numerator, the numerator going to the denominator when it comes to negative exponent. And b becomes positive, but also numerator. After that, we have to apply based on the laws of exponent. We just manipulate the power of a, that is 8 plus 5. Same base, you just add the exponent. That will becomes a to the 13. And b, that will be 12 minus 7. That is b to the 5. And what about this one? So instead of 9, 9 can be written as 9 squared. That can be written into 3 raised to the power of 2. That comes from 9. That is 3 times 3 is 9. So you have to simplify 3 to the power of 2 raised to the power of 2. That will becomes 3 to the power of 4. So here, instead of 9, we just replace it 1 by 3 to the power of 4. And for the base, since 3 and 3 have same base, we just subtract 4 minus 2. So there are 2 powers when it comes to 3. And we get 2 by simply subtracting 4 minus 2, that is 2. And of course, the final answer, we have to get the 3 squared, that is 9. A to the 13, b to the 5. So this is your final answer. 9, a to the 13, and b to the 5. Here in second example, just simply multiply the numerical coefficient of 4 times 2, that will becomes 8. And for the m, we just add 3 plus 2 exponent, so there are 5m. And also for the n, there are 6, 1 plus 5, 6n, all over 8n to the 7n. And 8 divided 8, that is 1. And of course, 7 is bigger than 5, so we just write m here in the denominator with an exponent 2. So since 7 is bigger than 5 and we don't have negative, so this will become denominator when it comes to the quotient. And for the n, 6 minus 1, the n is 5. So this is your answer. And to the 5, because we can cancel 8. And for the m, that is 7 minus 5. The reason why here in denominator, because 7 is bigger than 5. Then for the 6, that is 6 n to the 6 times, and there's an imaginary 1 in here, so 6 minus 1, you have 5. That's all.